All right, so we have a pair of angles congruent here, and then we've got labels for two pairs of sides. So we're kind of down to, we don't have any way of coming up with other angles, and we don't have all three pairs of sides. So we're down to those two choices. So now let's set up a proportion and see if these sides are proportional. So we can say 2.4 is to 2.4, as 1.8 is to 1.4, and hopefully you see already that these are not equal. The left side simplifies to 1, the right side not 1. So since these are not equal, we would say not similar. So choice D. So not similar. Um, all right. Here again we have a pair of angles, two pairs of sides, and so we're thinking probably side angle side or not enough, either not congruent, not similar, excuse me. So let's set up a proportion. I'll do the smaller side over here, 16, over the smaller side over there, 20, and potentially equal to 24 over 30. You can simplify both fractions, divide them both by 4 on the first one, and you get 4/5. On the second fraction, divide them both by 6, you get 4/5. So these are equal. If you change them to both to decimals, you get 0.8, 0.8. So by side angle side, we can say that these are similar. All right, here we have an angle that's used in both triangles, so reflexive property there. And then we've got these two angles that are corresponding angles. You can also come up with this pair of angles by corresponding angles as well. So once you get to two pairs of angles that are congruent, we have enough for angle, angle. So the true triangles, so the small triangle and the big triangle are similar by angle, angle. Number 4, we've got two isosceles triangles. So let's see, I guess I'll do the smaller over the bigger. 1.8 is to 2.4 as 1.8 is to 2.4 as 2.4 is to 3.2. Trying to see if these are equal. So notice that 2.4 is shared in both triangles. In the smaller triangle, it's the longest side. In the bigger triangle, it's one of the smaller sides. So obviously, this first pair of fractions are equal. We really just need to see if these are equal. So you can change them both to decimals, do 1.8 divided by 2.4. We get 0.75. Do 2.4 divided by 3.2, and we get 0.75 as well. So these are in fact equal. And so by side, 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 we can say these triangles are similar. Which statement is not true? Okay, so AB is to XY as AC, first and third, is to XZ. Since those are similar triangles, then the sides are proportional. So that one is good. All right, Y is congruent to C. We don't have enough information to know that that is always true, so this is false. Let's check the rest. A congruent to X, that's true. And then XY, first and second, is to AB, first and second, as YZ. second, and third is to BC. That's true. So choice B is the only one that's false. All right, we can find the perimeter of triangle ABC by adding up all sides. So 3 plus 4 plus 6 gives us 13. Now the perimeters have the same ratio as the scale factor. So 4.5, that's PQ, is to AB. So 4.5 is to 4. As the perimeter that we don't know, I'll just call that P, is to the perimeter of triangle ABC, which we now know is 13. So we just need to solve for P, multiply both sides by 13. So we get 14.625 for the perimeter of triangle PQR. The other way to attack this problem would be to find the measure of each side length. So figure out this value and then add them all together. We've got parallel lines here, so alternate interior angles are congruent. And if you want to go and match up the third angles by vertical angles, you can do that. So these triangles are similar by angle to angle. And so these sides must be proportional. So basically, if you rotate this in this direction 180 degrees, then you'll see the way that they correspond. So you would have something like this. So x plus 2 is to x minus 4, as 18 is to 6. If you happen to realize, oh, 18 divides by 6, that gives us 3. That'll kind of make your job a little easier. You can cross multiply here. 1 times x plus 2 gives us x plus 2. Distributing the 3 as we do it here, or actually I'll write it out. Distributing the 3, we'll get 3x minus 12. And then we'll need to get the x's together, subtract x from each side. So we have 2 equals 2x minus 2, minus 12, excuse me. We'll add 12 to each side, and we'll get 14 equals 2x. Divide both sides by 2, so 7 is x. So we found x. To find AB, plug it back in, 7 plus 2 gives us 9. To find AC, do 7 minus 4, and that gives us 3. So we found x, AB, and AC. Number 8, we've got similar triangles, and so we want to find CE, so I'll call that x. Well, CE is third and first, so it matches up with AC. So x is to 3.7. As be consistent here, so I chose one from this triangle, so 8 is to 4. If you happen to notice that it simplifies, you're welcome to do that. If not, we're trying to get x by itself, multiply both sides by 3.7. So 8 divided by 4 is 2. 2 times 3.7 gives us 7.4 for the distance from C to E. Number 9, trying to figure out if these are similar. So let's look at the lengths. AB is 3 and HI is 6, here to here. So when we compare the lengths, we get 3 over 6. When we compare the widths, we get 1 over 2. Are these equal? If they are, then we have similar shapes, and we can write our similarity statement. Divide both the top and the bottom of the first one by 3, we'll get 1/2 equal to 1/2. Of course, that's true. So these are similar, and then we need to complete the similarity statement. So AB, that's the length. So we need to do either HI or JG. So I'll go HI, JG. Notice that AB is a length, HI is a length. CD is a length, JG is a length. The widths are AD and BC, HG and IJ. So these are similar rectangles. We have 2 of the 3 angles, and so if we can find the third angle in either one of these triangles, then we will know whether or not these are similar. So we've got two 67s. 67 plus 67 gives us 134. Subtract that from 180. And so we get 46. So these are in fact similar triangles. So by angle, we can say that these triangles are similar. Now we're going to set up a proportion and solve it. So these sides are proportional in similar triangles. So we can say x is to 30 as 20 is to 25. To solve this proportion, we can multiply both sides by 30. So 20 times 30 gives us 600. 600 divided by 25 gives us 24. So x is 24. This is a dilation from the origin, so we're just going to multiply each coordinate by 1/2. So -4 times 1/2, -2. 4 times 1/2 is 2. So just keep multiplying each of these coordinates by 1/2 for the dilation. 9 times 1/2, 4.5 or 4.5. And then 0 times 1/2 is 0. Again, multiplying each of these by 1/2, we'll get -5 and -1. So we found the coordinates of this dilation. All right, we have an angle bisector in the triangle. When you have an angle bisector in the triangle, it will split up that third side into segments that are proportional to the other sides of the triangle. So if this full length here is 7, then if we take out the x part, we'll have 7 minus x. So we can say x is to 8 as 7 minus x is to 6. And we can cross multiply, or we could multiply both. Yeah, I guess cross multiply might be a little more efficient. 6 times x, 6x. And then distribute this 8 as you do that. We get 56 minus 8x. Add 8x to each side. Divide both sides by 14. And so x is 4. Trying to find the scale factors, so let's compare the smallest sides, I guess. So 4 to 14. Oh, and make sure this is the one on the right would be the new one over the original. So yeah, I do have that set up right. 4 over 14, which would simplify to 2/7. If these are in fact similar, all of these should give us the same value. So 6 over 21, divide them both by 3. We get 2/7. This one we're dividing them each by 2. And then 8 over 28, divide them both by 4. 2/7. So we do have a scale factor of 2/7. All right, 14. We have 2 of the 3 angles in this triangle, so let's find this third angle. Add the 2 that you know together. 37 plus 65 gives us 102. Subtract that from 180. We get 78. So we have a pair of angles that are congruent. Now we need to see if these sides that we know are proportional. So just be consistent as you set it up. So if I go with 18 over here is to 12 as 30 is to 20. And we're trying to figure out, are these equal? Several different ways you can do it. You can divide them both and you get 1.5. So they are equal. You could cross multiply, do 20 times 18, you get 360. 12 times 30, you get 360. So whichever way you do it, you do get that these are proportional. So the sides are proportional, so these triangles are similar by side angle side. So we can say triangle TUV is similar to triangle. Now make sure you have it in the way they correspond. XZY. All right, and the goal here is to find angle V. Well, angle V will be congruent to angle Y. And so it's this angle, so 65 degrees. We've got 3 parallel lines, and so it will create segments that are proportional. So we can say that x is to 5 as 9 is to 6. Multiply both sides by 5 to get the x by itself. And so we get 45 over 6. And if you divide that, you get 7.5. So x is 7.5, or if you prefer the fraction mixed number version, 7.5. All right, you may remember some things about geometric mean. If you don't remember that, you can set up your similar triangles and figure it out that way. In order for me to figure out JL, I'm going to need LM, and once I find that, I can add it to JM. Rather than using the idea of geometric mean, I've just drawn out the triangles in the way that they correspond. And so now I can say that x must be to 20 as 20 is to 25. So multiply both sides by 20. When you do that, you'll have x equal to 400 divided by 25. And so you'll have 16 for x. 16 plus 25 will give us LJ, or JL. So 41 is the distance from J to L. All right, here we have parallel lines cut by transversal. Corresponding angles are congruent. We have enough for angle between the two triangles. You may also remember, and so you could set up a proportion that way, or you may remember that if you have a line drawn parallel to a side in the triangle, then it's going to set up segments that are proportional to each other. So we can write x over 5, x is to 5 as x minus 3 is to 4. You can cross multiply there, 4 times x, 4x, and 5. Make sure you're distributing the 5. 5 times x is 5x, 5 times negative 3 is negative 15. Get the x's together by subtracting 5x from each side. So we have negative 1x equal to negative 15, and then divide both sides by negative 1. So x is 15. Our goal here was to find x. Here we want to do a dilation, 2 units, and the center of dilation is here. So here is our scale factor. And our center of dilation. All right, so we're centering this dilation about B. So when we dilate B, it'll stay at that same position. Distance from B to A is 2. So if we multiply that distance by the scale factor, 2 times 2 gives us 4 for the distance from B to A prime. So we will travel down 4 units in order to find A prime. Now A to C is 3 units, so if we double this distance, we do 2 times 3, we get 6 for A prime to C prime. So travel to the right, 1, 2, 3, 4, 5, 6. We have all 3 vertices of the triangle, so now we just need to connect them to form the new triangle. So hopefully this extra set of review problems will help you prepare for the test on similarity.